Welcome. For this video, we will be discussing about Power Lab and LabTutor. So we will show you the basic setup of a Power Lab, and also we will have a walkthrough on how to use LabTutor in our physiology laboratory. I'm Dr. Rosita Roldangan from De La Salle University. Let's start. So here we have the basic setup of a Power Lab. So as you can see, these are the hardwares. Okay, so these are the hardwares of the basic setup for Power Lab. So the components would be your computer. So here you have your CPU and then the monitor, which is connected to the Power Lab box, this one. Okay. And then, the Power Lab box is now attached to the paraphernalia. These are usually the transducers, signal transducers, which we now attach to our subject. Okay, so basically, these signal transducers generate an analog voltage, okay, that will now be transmitted from our subject going to the Power Lab box. Okay. And then, so as I mentioned, the transducers, okay, basically, you have this in your handout, okay, so transducers receive input from the subject, like your pulse, chest movement for breathing, electrical impedance by the heartbeat, muscle twitching, and so on. So, whatever signal it receives, it will now amplify and then transmit it to the Power Lab. Okay, and then from the Power Lab, okay, within the Power Lab, it will now filter and convert these analog signals into digital signals. Then it will now transmit these signals to the computer, which in turn would now display the detected signals into waves and numbers that we can analyze. So now let's focus on the hardware. Okay. So again, that's the computer, okay, which is attached to the Power Lab box, which are then attached to the transducers. Okay. So in your handout, you are given different types of transducers and other paraphernalia that are attached to the Power Lab hardware. Okay. So let's focus now on the Power Lab hardware. Okay, so here we have the front panel of the Power Lab hardware. So this one, the one that I pointed at, okay, is the on-off switch. Okay, so make sure to turn it on when we are already conducting the experiment, and then always turn it off so that it will not receive any more input once it is turned off. Okay, and then here on this side we have the power light indicator, so that will now tell us if it's turned on. Okay, and then here we have the input port. Okay, so we have two available input port for this type of Power Lab. Okay, there are other Power Lab hardware that can have even a dozen of these inputs. Okay, so for us, this is just a very basic setup. We only have two input ports. Okay, so as you can see, one transducer is already attached to input port 1. Okay. Here we are pointing to the output port where you attach connectors going to the computer. Okay, and then now for the rest of the ports, so these are for other sensors that we can also attach to our subject. Now let's look at the back panel of our Power Lab hardware. So you can see here, this is the power switch, okay, main power switch to turn on and off the hardware. And then beside it, you have the power cord connector port. And then we have here several ports, input ports, output ports. We even have a USB port that we can use to connect the Power Lab hardware to the computer, to USB, and to other machines. Now let's shift our focus on the hardware. So before, we used to have LabChart as our software to process the signal coming from Power Lab. But then, it has been replaced by the manufacturer with the LabTutor, which we are now using. And as of December 2019, I believe LabTutor is already also being sacked by the manufacturer. So expect that in the coming months, starting 2020, in the coming years, if you are planning to purchase Power Lab for your institution, then you will probably have the newer version, which I think is still friendly, actually more friendlier than LabTutor. And they even have demo videos already, okay, included in their package. So it's going to be much easier for people to learn how to use Power Lab in their physiology exercises. Okay, so as I mentioned before, we used to have LabChart. Okay, the advantage of LabChart, the one that we used before, is that you can actually tweak the stimulation parameters such as voltage, amplitude, frequency, etc. So if you're conducting a research, you can easily modify the parameters that you need to meet the conditions that you wish to study. Okay? But then the disadvantage of LabChart is that you need to also tweak the very same thing. You need to tweak the stimulation parameters in order to generate the output that you wish to demonstrate in the lab exercise. So sometimes, okay, it gets frustrating, especially when you're really not a tech person. You might end up with a result that is not what's expected in the exercise just because you failed to adjust one of the parameters. So if you're not really well versed with technology, this might be quite difficult for you. So the user needs to be very familiar with the LabChart software in order to use it efficiently. Okay, so but now we have LabTutor, which is very friendly to beginners. Okay, so the software will literally tell you what to do and when to do it and how to analyze the data. Okay, so as long as you can read and understand, it's very easy to use LabTutor. So of course, open the computer, and then for this computer, the software LabTutor is already installed, and we already have a shortcut icon on the desktop. So once you open it, okay, it will now show you the login page. So you input your username and your password. So for LaSalle, it's the lab technician that is in charge of our accounts. Okay, so usually he's the one that gives us, he's the manager of our Power Lab. So he gives us our username and password. Okay, so now we will open, okay, our first exercise and learn how to use exercises that have been designed for our course. Now, there are a lot more ready-to-use exercises available, but these are the exercises that we have chosen. Okay, so let us now click on Introduction to LabTutor, this one. Now, this brings us to the first page of our first exercise. Okay, so you may have seen this slide before if you have already gone through the PowerPoint that I have uploaded in Canvas. Okay, so more or less, for the objectives, so we want to familiarize with the major hardware and software components of the LabTutor system, able to record basic finger pulse signals in LabTutor, and able to use some of the annotations and analysis features in the LabTutor software. Okay, so I will not make this into a reading session. These are all given in your in the Canvas already. Okay, so basically these are the old types of this shows you the history of Power Lab. So starting from the chemograph, which it was quite cumbersome to use, especially for my generation who used to have chemographs as their high-tech machine before. We were covered with carbon suit. Literally, we smoke the drum, this one, drum. We smoke this so that it will turn black. And then, basically, there's going to be a pin that is now going to scratch on the surface of the drum. So that as the drum is turning around, the needle, okay, that is now on the surface of the drum will start scratching the surface, and that will now give you the waves, okay, which will now show us, okay, for example, muscle twitch, okay. And then of course the first generation computers already came out, okay, in the 60s, and then here we have the newest version already. Okay, this is actually quite basic. We have a lot more sophisticated, but we want to have this very easy to use. At least you will not get too culture shocked in case you go into a more sophisticated laboratory later on. Okay. Okay, next we have here the data acquisition. So this is still in your Canvas. Okay, so we have the setup as we have already mentioned. So on the subject, you have the transducer, which is attached to the Power Lab hardware. So it converts mechanical signal to analog signal. And then from the Power Lab hardware, it is then filtered. Okay, and then the digital signals is now transmitted to the computer for display. So these are the five conversion of signals. So from the input, it gets amplified by the transducers, it gets filtered and sampled by the Power Lab hardware, and then it is displayed by the computer. Okay, and then we already showed you, okay, the Power Lab hardware unit, okay, the front panel and the back panel. And then here, we don't have this anymore. Probably in some laboratory they would have this signal conditioner, but for our setup we don't have this. But what we do have are some of the signal transducers. So it's very easy to identify them, okay, and they are already their use is already defined on the PowerPoint that I have sent you. So you basically you have the event markers, you have the stimulation nerve muscle apparatus, and then you have the force transducer. We do not have chemical property sensors. So we will just go through them. We will encounter each one of these transducers as we go along our different exercises. Now, we already discussed about the front panel and the back panel. Okay. And then here you have some tips on how to organize your LabTutor experiment. Now, we will start with the most basic setup. So this is our walkthrough on how to use the LabTutor, okay, and together with the PowerPoint. So for this procedure, okay, first of all, make sure that the Power Lab is connected and turned on. And then you place the pressure pad of the finger pulse transducer against the distal segment of the middle finger or thumb of either hand. Use the Velcro strap to attach it firmly, neither loose nor tight. So this is the transducer, okay, and this is the sensor, okay. So this side of the sensor will now have to face, okay, your fingertip, okay, the pad of your fingertip, and then when you put it around your finger, okay, tight enough, okay, but not too tight that you lose all your blood supply, okay, going to the tip of your finger, and then the other end of the cable you attach to the input port 1. Okay, so here we have a this is not a makeup tutorial. So here we have an actual demonstration of how to attach the transducer onto the finger. How wonderful it would have been. This is the actual. We're able to actually do this hands-on, but then our normal. Okay, there you go. Not too tight, not too loose. Okay, then the other end. You attach to the input port 1, and then of course make sure that you turn on the isolated simulator port so that your Power Lab hardware will start receiving signals coming from the transducer. Now, I am so sorry for the wonderful video that you are seeing right now. Okay, so this is what happens when you are a doctor and not a professional videographer. Okay, so let's see how we are going to record our data. This will clear up. Okay, so as you can see there, I just clicked, okay, start button. So after you have attached the transducer to the pad of your fingertip, so you turn on the isolated simulator on-off switch, and then we now focus on the software. Okay, so you would now be able to see a value panel. Okay, so basically this is your value panel. So this will now show you, the upper box will show you the waveforms that will be generated by the pulse coming from my fingertip. And then below here, okay, which is so clear, okay, you will actually see later the timer of how long the recording has been happening. So hopefully in a while, the video will clear up. Okay, so you can see now that we are generating our pulse waveform. So the beauty of using Power Lab and LabTutor is that the waveforms, wonderful, it finally cleared. Focus, okay? So as you can see here, the waveforms that you used to see on your textbooks. Okay? Using the Power Lab, we can actually generate those waves. So that when you start learning about the A waves and C waveforms, you actually have a more concrete feeling of how those forms were actually generated. Okay? So this one is our pulse waveform. Okay? So this is the waveform generated by the pulse of my fingertip. Then you can see here the timer, how long. So more or less, we actually recorded around 28 seconds. Okay? So because according to our so as you can see, this is a very friendly software, okay? So it will actually tell you what to do and when to do it. So all you have to do is read and understand. So click the start button. So after putting on my transducer, okay, so it said click the start button. And since I'm quite obedient, okay, so I click the start button and then we started generating the waveform. Okay, now and then it said after 20 seconds click stop. Okay, but there's one thing here, okay, called the auto scale button. Okay, so let's see what is the auto scale button. Okay, there you go. So another friendly feature of LabTutor is that if it has a technical term, it's in blue. So that once you click it, it will actually pop up a window that will explain what that term is, and it will actually show you the picture of the icon of what it is talking about. So here we have the auto scale button. Okay, so clicking this button in the toolbar of the LabTutor panel allows you to auto scale the data. So we have to look for this icon, okay, which is actually this one. Okay, so friendly, no? Okay, so we found that. Okay, so as we click it, what happened? The waveform adjusted, okay, so that it will maximize, okay, the screen, okay, so that the screen will be filled up, okay, to the optimally, okay, by our recording. So as you can see, as the waveform became taller, the scaling, okay, in the vertical axis, okay, also adjusted. So you can still have the same measurement. So by the way, this is so 0.2 amp, okay, 0. So the amplitude, okay, is the same. When you click the auto scale, the data will now be scaled to occupy the most of the height of the channel. So this is one channel. Okay, so this is one channel. So you will use the auto scale button frequently to optimize the display so that you have the most beautiful wave, okay, that is easy for you to analyze and refer. Next, we have scrolling. Okay, so for scrolling, the scroll bar allows you to move back and forward through your file. So remember, we had around 28 seconds of recording. So you cannot have all 28 seconds in your screen at the same time. So here, down below, you have here your scroll bar that you can slide across so that you can move forward and backward. okay, in your recording strip. So the scroll bar is primarily an analysis tool allowing you to review and locate data of interest anywhere within a file. So during recording, you can also review your data without stopping recording. Okay, so even though you are continuously recording, you can just go up and down. It will still continue to record at the very end. Okay, by initiating scroll review mode, scroll review mode is engaged by either dragging the scroll bar thumb to the left or clicking anywhere in the incoming data. So basically what that means is you can just go here and then click, okay, and then your scroll bar will immediately jump towards that region, okay. And then you can also, you can also go to move to end of the data. So if you've been wandering around so much and you don't know already where is the end of your recording is, okay, you just click the move to the end of data button, okay, and this will immediately send you to the to the latest, to the end of the recording. Okay, so in case the recording is still ongoing, you will immediately go to the current moment of recording. But if you're already done with recording, you will just basically jump to the end. Okay, so here, this is the icon, okay, for the move to the end of the data button. Okay. So, well, I was trying to keep it here, but then I forgot I was already at the end. So when I discovered my mistake, okay, so I actually the scroll bar back a bit there, and then here I click the to the end there. Next, we have the horizontal compression button. Okay, so with this button, it's located in at the bottom left of the LabTutor panel. Okay, so you can compress or expand the time axis. So this one, the x-axis is the time axis. So it will adjust, okay, the interval, okay, the width of your time axis. Click a few times on the compression button to see what this does to the display. And then click the ratio button, a pop-up menu appears. From this, you can choose the compression directly. So, let's see. Definition of our horizontal. There you go. So, the compression button, here you have, if you want to increase the interval of the time scale, then you can click positive, and then negative if you want to make it narrower. Now, if you want to go straight to a ratio, okay, that you wish, you can just click on the ratio button. That will immediately give you a defined vertical and horizontal proportion of your waveform. Okay? Well, both for horizontal. Okay. So, by clicking positive, there, we need faster. Okay, and then, we need narrower. Okay, so as you can see, as the waveform are adjusting, the scale is also moving together before. Now here, the vertical button, okay, so use to expand the vertical part. There. Same idea as the horizontal button. Okay. So, auto scale. So, auto scale and default scale button, okay, after you have manipulated your waveform so much that it's totally unrecognizable, you can always click the auto scale so that it will go back to its original form. Okay, so it will adjust the height okay, of the scale data that display the minimum and maximum data, so that your data will all fit or will all show up within the channel window. Okay, and then the default scale button resets the vertical scale and horizontal compression to their original setting after you have manipulated it so much. Okay. So here we have the definition of the auto scale button. So this is the auto scale button. So once you click that, we actually use this a while back. Okay. And then on the default button, annotating a record. So when you are already doing the different experiments, of course you will be modifying the conditions, and this will now change the waveforms that will be generated on our screen or in our channel. Okay, so that we will not be confused as to what we are recording on this particular segment of the time scale, we can actually put annotation or comment on certain time. Okay? So, record can be annotated. So, the comment panel, okay, here. So, below the value panel, we have the comment. That's where you can type in your annotation or your comment. Okay? So, for procedure, here. So, let's continue. Okay. So, we have here a new set of data. Okay. So, let's this star. So you click on this line. So actually, before you start things, click on this side and then click on that. There. Once the add button is on it, so at least you know that this is a new data. Very important. Okay, so you can make measurements and add the relevant number into the table, which is down here below. So you just place the cursor, your cursor, this one, over the data that the point that you want to measure. Okay, and then click to place the selected data in the value panel. Okay, so to insert the value into the table, just drag the value going to the table. So basically, here, okay, the value panel displays data values which can be obtained, for example, by clicking on a data trace. So this is the data trace. So you just click on the waveform and then the number of that value, okay, the intersect, the x and y intersect of that will be here. Okay, we'll now show you here. So this one shows you force. Okay, so And then, I will show you how you can drag this, okay, value to the table. Okay, next. First, we click here, okay? We click on the top, okay? The peak of your waveform, okay? So, the amplitude of that peak of the waveform is around 0.48, okay? And then, the time that, once you have here the start, okay, mark, this will go back to 0. So, as you can see here, this is already 29 seconds, right? So, since we have here a new set of data, this goes back to 0, the time. So, here, we were able to generate this waveform at around 0.87 seconds, okay? So, that's the time frame, okay? So, at 0.87 seconds, you had a height. Okay, the amplitude of your pulse waveform is around 0.48. Okay, so we just drag, okay, to the table the value, okay, generated, and let's on to the next one. Okay, so at 154 seconds, okay, the pulse generated had an amplitude of 0.36, okay, millivolts. Okay, next. Okay. So, by having this table, you can already see. Let's go back a bit. Let's go back. Okay. So, by generating this table, what are the things that we can already get from our data? So, you already have the time interval between your pulses. Okay, so at 0.87, you had the pulse. At 0.54 seconds, you had the pulse. At 0.22, you had the pulse. Okay, so from here, you can already determine your pulse rate, okay, the frequency of your pulse. And then here, you have the amplitude of the pulse. Okay, so is it regular? Okay, is the pulse regular? Is the pulse weak? Is the pulse strong? Okay, you can already see from this data. Marker. So, marker, when the marker is used, values and time displayed in the value panel are relative to the marker position, because a while ago, everything was relative to the 0, okay, to the start of our data. But then, if you don't want to start in that data, for example, there's a lot of noise at the start of your recording, and you are waiting until the noise goes away before you start considering the data that you are generating, then you can use marker to use that, okay, as the starting position. The marker, okay, resides on a dock at the bottom left of the LabTutor panel. From here, it can be dragged and dropped, okay, onto any part of the data. To return the marker to its dock, simply click on the dock area. Okay, so drag the marker from its home and drop it somewhere on the trace. The marker does not have to be placed exactly on the waveform. Okay, so LabTutor's marker. Okay, so basically, even if you don't hit the exact location, you already know what you are trying to your intention, okay? So, here, this is the marker button, Okay. So there you have the marker button. Remember your horizontal scale and ratio button. Okay, just above that you have your marker icon. Now here, as we click, okay. So this is the one, okay, that we want to mark. So mark. Okay, so we mark the peak, and then now we go to the throw of your waveform. Now because our marker is on the peak, and then the next point, okay, is on the throw of your on the trough of your waveform, then it will now show you the difference in the height of your pulse. Okay, so you have change in time and change in pulse amplitude. Okay, so this time it will really show you the actual height of each pulse wave that you have generated, and then it will already tell you the interval, okay, between each waveform. This time we will do some calculations. Okay, so the LabTutor can be configured to calculate variables based on the raw signal input from other channels. So here we will already show you different parameters. Okay, so different parameters will be shown in different channels of your screen. This can be displayed in real time on the channels. Okay, and you are not using for data acquisition. Okay, so basically we just click start. Okay, and then you can also click the comment panel. Okay, as we change our conditions. So for this one, channel 1, okay, you will see that in your waveform screens, the channels, okay, you have 3 channels. Channel 1 will show us the waveforms generated by the finger pulse. Okay, then channel 2, okay, it will actually show us the interval between the peaks of the pressure waves. So if the graph or the line that you will generate is quite erratic, what does that mean? The height of the pressure waves are actually very different from each other. But if you have a waveform that is almost equal, like a straight line, almost a straight line, that means that the finger pulse, the pulse waveform, are almost the same height. Okay, and then for channel 3, it will now calculate your heart rate. Well, actually more accurately, this is your pulse rate. Okay, so it will show you the interval of each pulse waveform. So just like in channel 2, we don't want to see a very erratic line on channel 3, because if you have a very erratic line in channel 3, meaning it goes up and down, that means the interval between your pulse waveform, okay, vary a lot. Okay, it goes fast, slow, okay. But if it the pulse waveform is generated at a rhythmic, regular pacing, then the interval should be almost the same. So that means the waveform that we will generate should be almost straight, so that we can say that it's a regular pulse. Okay, so there you go. Okay, we will now add the name. So volunteer A. No choice, because I was the only one there. Okay, start. channel 3, you have the pulse rate. So as you can see, okay, the waveform generated. Okay, the waveform generated, you can see that the interval between no, not the interval, well, the height, okay, this actually pertains to the height. The height of your waveforms are almost the same, okay? So sometimes it can deviate a bit, but then that is human physiology, okay? We're not robots. And then for the pulse rate, maybe I got a bit too excited, okay? Here on this part, okay? But then that's as excited as I am. So, what can we, what's our takeaway from this data? So, the interval is around just a little bit after 0.25, right? So, I'm generating a pulse every 0.25 seconds. And then, if we convert that to pulse rate, okay, my pulse rate is just a little bit over 80. Okay, more or less, I'm just there at around 80. 80 up to 85. Okay, so that's the range of my pulse rate. For deleting data, sometimes, okay, we can have, we repeat our exercise if we made a mistake in the procedure or we did not generate the correct, the expected observation, or maybe it's too noisy, then there's this segment of our data that we need to delete, okay? So here we will teach you how to delete that part, okay? Now, just remember that once you delete data, okay, there's no going back. Okay, that's final. Cannot be undone. Okay, so you have to be sure that what you're deleting should be deleted. Okay, before you do that. Okay. So, let's add what the delete data button looks like. What I did here, okay, for example, this part up to a certain part way back there is the region that I wanted to delete. So basically, I just click here and then drag going back so that it will be shaded. Okay, so you know that once you press the delete data button, the area or the region that is shaded will be the data that is going to get deleted. Okay, so in case you were able to shade part of the data that you do not want to delete, then you have a warning, okay, of what the area that is going to be deleted. Okay, so I wanted to delete this part, so look at here. Okay, we have the X. Okay, so that is the delete button. Are you sure? It's there. So as you can see here, this is the part, okay, that has been deleted. Now, in case you don't want to get confused, you can always annotate that that part of the data has been deleted. Now, going to the very end of our exercise. so here we have our report. So as you are performing your lab exercise using LabTutor, the computer is already generating your report. Amazing. Okay, so you don't have to really draw anymore. For all the art challenge scientists out there, this is actually quite good for you guys. Okay, so for the report generated by LabTutor, so it will show your group. Okay, so it will show your username. Okay, so here you have your username, but you can always edit that. It will even tell you when you started your exercise and the day that you did your exercise. Okay, and then here you have your guide questions. So this is actually part of your assignment later on. Okay, so as part of your assignment, okay, you have to answer the guide questions which are at the report section of your exercise. So I would expect that, so on your Canvas, I will be posting there an assignment module wherein you can submit your lab report for this exercise. Okay, Introduction to LabTutor. So first is, on your own words, briefly describe the function of the Power Lab component shown above. Okay. And then next, on your own words, describe the function of the labeled parts of the Power Lab above. Okay. So those pointed features on the front panel of Power Lab. And then here we have a recording of our finger pulse. Okay, so the ones that we were performing is automatically generated at the end in your report. Okay, so today you use a finger pulse transducer to collect some physiological data and make some recordings. In your own words, being as specific as you can, describe what is actually being recorded by the Power Lab and displayed in LabTutor. Then next, name 2 physiological variables other than finger pulse that you could measure using Power Lab and LabTutor. So, do you have any idea what other physiological variables you can test using this contraption? And then fifth, were all of your measurements identical for every member of your group? So let's just do a hypothetical scenario. Since we only have me as your guinea pig, okay, I will already tell you that the measurements for every person is not identical. Okay? So, the answer that you need to give me is, would you expect them to be identical? Okay? And why not? Okay? So, I'm already giving you a hint. Okay? So, part of the answer here is that measurements should not be identical with every person. Okay? So, explain to me why you will not expect it to be identical. Okay? And next, we have deleting data. So, this is the data generated. Okay? Now, showing us the part that has been deleted. Then, can you think of some parameters that the LabTutor could calculate based on your original pulse trace? Okay, so more or less I already gave you a hint on the calculations, okay, that you can generate from the data, okay, generated by your pulse waveform, okay. And why is it important that the data in all channels be deleted simultaneously? So you would notice when I was shading, okay, a region of one channel, you would notice all other channels, okay, are also shaded. So that when I deleted one segment of one channel, all the segments, okay, corresponding to that region that are in other channels were also deleted. So tell me, why is it important that the data in all channels be deleted simultaneously? So that's the end of our session on the introduction to Power Lab and LabTutor. So I hope you will still have a chance to do hands-on, okay, one of these days, so that you will have an actual feel of how to use Power Lab and LabTutor. So I would expect your assignment, okay, before the deadline. So thank you so much.